live from the Taipei Music Center in Taiwan. This is NVIDIA GTC Live at COMPUTEX.
The eyes of the tech world are on Taipei as thousands gather at COMPUTEX, one of the world's largest showcases in the industry with a focus on AI and robotics, next-gen tech, and future mobility.
This year, NVIDIA's founder and CEO, Jensen Huang, will open the conference with his signature keynote address.
Until then, we've gathered some of the brightest minds and biggest names in tech to discuss the company's past, present, and future. The stage is set, the lights are bright. It's time for NVIDIA GTC Live at COMPUTEX.
Hi, I'm Ben Reitzes.
And I'm Brady Wang.
Brady, I'm really excited to be here because as an equity analyst who closely covers NVIDIA at Melius Research in New York, I know that the tech community, along with investors, are looking forward to hear how Jensen and his team are driving the AI revolution forward. You know, the products and initiatives announced here set the course for the AI market, not only in terms of chips, but they also draw attention to an entire ecosystem that drives the creation of real-world applications that can use the technology. You know, you can sense here, Brady, a lot of excitement around autonomous AI agents, physical AI, which is led by robotics, and advancements in amazing reasoning models, which really are just still moving at a breakneck speed. So with that, I want to turn to my co-host, Brady. You're from Taipei. What does this mean, COMPUTEX mean to the community here?
Yeah. Hi, everyone. I'm Brady Wang from Counterpoint, and I'm excited to have you here in my hometown, Taipei, Taiwan. 欢迎来到我的故乡台北，台湾。We are at COMPUTEX, a huge tech event that started back to the 1981. Over the years, it has become one of the most important stages for showcasing new technologies. Now, it's placing stronger focus on AI and how it's shaping the future. It's a gathering point for the global tech communities where ideas are shared and innovation takes off. This year, GTC Taipei kicked off as one of the first key events at COMPUTEX, setting the tone for the week ahead. Thank you for joining us, and let's dive to the exciting world of tech, GTC Taipei at COMPUTEX.
Well, as you can see, guests are filing into the venue. And you can see that behind us. But as the anticipation builds for Jensen's big keynote, which is coming up soon. But today in our pregame show, we're going to explore 3 chapters of NVIDIA's story that showcases how it remains at the center of critical partnerships across Taiwan. To that end, some of Taiwan's and the world's most important companies are joining us to set the table for Jensen's big keynote, sharing their unique perspectives and histories from the front lines of AI innovation. So right now, let's take a look at how NVIDIA's humble beginnings grew into something that is changing the world at a remarkable pace. To help us kick off today's conversations is someone I've known for over 20 years, Jeff Clarke, the COO and Vice Chairman of Dell, a company I actually cover as an equity analyst as well, so you're near and dear to my heart.
And joining Jeff is the Dr. YJ Mi, Executive Vice President and the Co-Chief Operating Officer at TSMC. Welcome.
Thank you.
Thanks for having us.
Great to see you. So, Jeff, I was hoping you could tell us quickly why you're here in Taipei.
Well, real simple. Jensen asked me. Which is no small task given we have Dell Technologies World kicking off in a few hours in the United States. But how could you say no?
Yeah, he's got a way with people, right?
He does.
Yeah. Well, maybe, Jeff, you can walk us through your take on the evolution of Dell's partnership with NVIDIA, starting from the early days, the gaming card integration, all the way to these complex full-stack AI systems where you're generating billions of revenue together.
Sure. I was thinking about when the first time I met Jensen, which best of my recollection is early 1996. Back in the day when 3D graphics was really making its inroads inside the PC industry. And we started our engagement with NVIDIA. If I recall correctly, it was our Dimension desktop. It was the Riva 128. We put it on the map, and the rest is sort of history. We were on the back cover of PC Mag, which back in those days meant something, where that was a real piece of marketing collateral that drove demand, performance leadership. And from that very point, we've had a very close partnership with NVIDIA. We've had many first-to-markets, many performance leadership products, breaking into new markets like the professional workstation market that we entered in 1997. We entered with Jensen and his platforms and products shortly thereafter with what became the Quadro product line, the professional graphics. We've been doing work, I think, deep-level collaboration for, again, many, many years that led our way to GPUs, led our way to ultimately the things that we're building today, and ultimately to the partnership that I'm trying to showcase here today, the Dell AI Factory with NVIDIA, which is ultimately a deeply integrated system and taking the pursuit of accelerated computing and the architectural transformation that's underway today, working together and doing things that were nearly impossible just a handful of years ago.
I love that shirt.
I do too.
Yeah, you got the Texas logo on the arm. It's good.
Hi, I'm YJ. I believe TSMC and NVIDIA has been working for a long time, and both share the same engineering background and also have a very high commitment to the qualities. So what do you remember about the early days of working together with NVIDIA, and what made the partnership so special?
Yeah, I think the unique partnership between NVIDIA and TSMC began in 1997 when our founder, Dr. Chen, personally reached out to Jensen Huang in response to his request for a foundry service. And after initial connection, we have worked together, cultivate a very deep and enduring collaboration. And NVIDIA's first product, as Jeff also mentioned, the Riva 128, and also Riva TNT, a star production in TSMC at that time. In TSMC's newly established 8-inch Fab 12. Actually, at that time, I was Fab 12's engineering manager, responsible for the quality and yield of that particular product. So since that, until 1997 to 2017, yeah, I think TSMC has delivered over 6 million 12-inch equivalent wafer to NVIDIA. I think the number grows, but we won't be able to release the new number because it's not the public information. However, it's obviously that TSMC and NVIDIA will grow together, and we are thrilled by the remarkable achievement that NVIDIA has achieved, become the global $3 trillion industry leader.
Wonderful. Yeah, 1997.
Yeah.
That's the year I joined TSMC, but I left 5 years after 5 years.
Oh, okay.
Yeah. Well, YJ, really good to see you.
Mm-hmm.
Well, it's a legendary partnership that you have with NVIDIA. It's amazing. How's the technical collaboration changed over the years? Was there ever a time where you had to tell NVIDIA to change course, or vice versa, they had to tell you?
Yeah, I think my major engagements with NVIDIA start from when I engaged with Joe Greco, Senior Vice President of NVIDIA Advanced Technology team. And starting when we were doing the development of 28 nanometer technology. And since that, we have driven the limit of innovation today to 3 or 2 nanometer, TSMC's most advanced technology, as well as our most advanced packaging, CoWoS, the SOIC, 3D die stacking technology. I think NVIDIA is always has the most challenging product with largest die size, very difficult to manufacture, require the highest standard of quality and yield. And, however, we work together very well and closely. And also we are always, NVIDIA is an amazing customer of TSMC. And it's constantly deliver revolutionary product to the world through TSMC's foundry manufacturing service. And at the beginning, we are just a partner on product design and manufacturing service, but now we work together very deep in technology collaboration and development beyond what we call the design for manufacturing or design technological optimization, or even today to system level integration.
So, Jeff, now we are in Taiwan, and we know Taiwan is the center of the chip production and also the system production, right? So could you talk about the Taiwan chip and the system pipeline that enable Dell's global executions for decades?
Sure, but maybe to build on a little bit about what YJ was talking about. I remember entering this industry, my first design was an 8086. Less than 50,000 transistors, 3,000 nanometers as we would cast it today. 286, 150,000 transistors, 1,500 nanometers. And now you're putting 100 billion transistors on a die at 2 nanometers.
Amazing.
It's a 3 million times improvement in density, 750 times smaller. That's what's enabling technology. That is why we're able to do and build the things that we're building today. And then you couple that, I was reflecting on my time here in Taipei. I think I first came in 1990, so I've been coming for 35 years.
Whoa.
I grew up in this industry with many of the tech giants on this island. And I think about the innovation they've brought, the manufacturing capability they've brought, the engineering capacity and capability, and it's enabling us to take a desktop market to become a notebook market, become a server market, network market, storage market, building out the fundamental infrastructure that our company needs, our customers desire to win in the marketplace. And I think about what's happening today with the computational intensity that we're getting out of the tremendous chips that are being manufactured, putting that together with high throughput, low latency fabric, taking that with some of the high-speed disaggregated storage architecture that we have done, you bundle that together and you build these enormous computers that are capable of things, again, that we didn't think of 2 years ago, 3 years ago that were possible to do. And we're solving huge problems, and we've only scratched the surface.
Yeah.
Well, YJ, sounds like you make the world go round. NVIDIA's got a lot of great products coming. We got Blackwell, GB200s, and then the GB300, Rubin. How are you collaborating about what's next? How are you shaping the future? We don't want to steal any thunder from Jensen, but how are you helping them make it happen?
Well, for TSMC, it's important for us to put the right technology at the right time, of course, at a cost that makes sense. And NVIDIA, one of the NVIDIA's greatest strengths is their ability and agility to adapt strategy, to keep pace with the ever continuous changing market trend. So throughout these years of collaboration, we have been able to develop a reason to work together, allow us to respond quickly and to cope with the fast-moving market trend.
How about you, Jeff? How are you adapting to move as fast on Jensen time?
Speed of light, you mean?
Yeah.
You've heard that, haven't you? The speed of light?
Yeah.
Look, I think what's happened is, for us, we've had to rebuild our engineering model. The time between new pieces of technology and its adoption has forced us to rethink, reinvent our engineering flows, how we produce the type of energy density, the GPU density, how we power and cool these things in record time. It's changed the way we've innovated. We're quite excited in our ability to respond, and it's the deep collaboration that we have with NVIDIA that's enabled us to do that. The yield was we were the first to ship a GB200 with NVL72. That was deep collaboration done in a very short period of time, meeting the market needs and to respond to what customers wanted. And with Jensen going, we need to get this to the marketplace, that's what's underway. It's changed the fundamentals of how we develop and deliver systems and solutions to the marketplace.
I've seen you work. This is the fastest I've ever seen you guys work. So, YJ, what are you excited to see today? What do you want to hear from Jensen today?
Oh, definitely. What's his outlook on the AI, the new era everybody is looking for?
Yeah, that's critical.
Yeah.
And we want to understand what the future application, what the future opportunities.
Yes, yes, definitely.
How about yourself? What are you looking forward to hearing from Jensen today?
How the flywheel's going to continue, how it's going to speed up, the types of capabilities that we'll build, and ultimately the problems that we will be able to solve and improve mankind, improve human progress. We're building incredible machines to solve problems that have never been solved before. That's pretty powerful.
Yeah, I mean, I agree. I'm really looking forward to what the applications are that he decides to highlight today. I think the whole industry is looking for it. Well, in summary, I think we heard a lot of great things here. I think that these are two of the deepest partnerships that NVIDIA has, longest standing partnerships. Dell, obviously, your history goes way back into the 80s, meeting Jensen in the 90s, and now adapting throughout the whole GPU journey. It's unbelievable, and I've seen it. I'm lucky to have a front row seat. And YJ, your company, without you, the world doesn't turn on its axis. It's really clear that everybody, what we see today from Jensen wouldn't be possible without you guys. So, we look forward to hearing more about you. Also, I say as an American, welcome to the U.S. I know you've already been there a while,
Yeah.
but we're looking forward to what you're doing in Arizona.
Yeah.
And, I can come visit anytime.
Sure.
So thanks a lot, gentlemen.
Thank you.
Just, great to speak to you.
Thanks
Thank
for
you so
having
much.
us.
Thank you. Thank you for having us.
Now, we'd like to fast forward to present day as enduring innovation and partnerships from the early moments are now being realized in the AI factory.
Let's welcome our next three guests, Eva Chen, Jonney Shih, and Mike Huang. Eva Chen is co-founder and the CEO of Chen Micro. Jonney Shih, the chairman of ASUS, and Mike Huang, EVP of Quanta Computer and the president of Quanta Cloud Technologies. Welcome.
Thank you.
Great to see you. Great to see you.
And hi, Brad.
Pleasures.
Thank you so
Nice
much.
to see you.
Nice to meet you here. Yeah.
I'm really excited to speak to you all. Eva, we'll start with you.
No, thank you.
So-
Maybe first.
Yeah, well, I think you're the only security leader that we're speaking to this morning. So, securing AI is a huge deal. We get asked about it a lot. I want to learn from you. How are you doing it, and how are you working with NVIDIA to secure AI? It sounds like a big job.
Wow, that's a big job because, if you think an organization is like a person, security before, we were just securing your leg, your arms, right? But securing AI is you need to go into the brain. You securing the brain and the whole nerve system where the AI is sending the information into all this nerve system. And if you think about IT industry, it's all about the computing power, transfer the data into information and generate intelligence for people to use, right? So this whole stack is hardware, all these people, muscle, to build all those hardware. And then I call it the infrastructure software, like BIOS, OS, network drivers. And then on top of it is application software, HR software, finance software, R&D software. Each of them then manage the data, analyze the data, and generate the functional intelligence. That was before. After AI, actually all the data are coming from the top and go into the AI model pre-trained, integrated with the whole computing power. And then the application is just utilizing all this intelligence generated from AI to present the data, right? Cybersecurity is a very special layer we inserted in between infrastructure software and the application software. We protect the whole information flow between all this software and east-west traffic information flow. So we require huge computing power to analyze all the data. That's why starting Trend Micro, actually starting 2002, we already tried to explore and utilizing the DPU from NVIDIA. And later on, also using GPU from NVIDIA to do all this security data analysis. But now, with AI, it's even more collaboration. For instance, we are using NeMo, finding the NeMo. We are using NeMo to train our LLM, specialized cybersecurity LLM called Cybertron. And then we also using CUDA. CUDA is the data analysis pipeline, right? We're using CUDA to make sure we can better analyze the data faster. And then we can detect the anomaly using Morpheus system. And then finally, we package all of this, including the LLM and our agent, the agentic AI, or the agent in NIM, in the NIM fashion. And therefore, we can faster deploy all this security into customers' AI infrastructure. So that, I think, a very deep collaboration with NVIDIA.
Thanks, Eva.
Yeah, there are a lot of insight. And you know, in the morning I talked to Eva, my brain is full of the hardware. Now, thanks for the explanations. Now I understand the critical of the software, especially in the hardware.
Yeah.
And Jonney, yeah, you are the legend of the Taiwan technology industry. And how is the ASUS approach to qualities and reliability and co-engineering with NVIDIA critical to scale the AI factory?
Jensen's vision on the AI factory is indeed the next industrial revolution. To push forward such an incredible revolution at light speed, like how Jensen always wants things, you know the importance of quality and reliability. Today's AI servers, packed with massive numbers of GPUs to maximize model flops, are pushing state-of-the-art, high bandwidth, high frequency, and high power design to the extreme, making signal integrity, power integrity, and thermal reliability absolutely critical. Quality and reliability have been the cornerstone of ASUS, starting from our day one making motherboards. We have always encouraged our engineers to master signal integrity, power integrity, thermal simulation, and computer architecture. For years, we focused on SOTA, state-of-the-art. It's incredibly, painful, but ASUS engineers love the challenge. Overcoming pain and bugs is a part of our DNA. So we love this kind of challenge, And we really enjoy the co-engineering with NVIDIA, which is indeed critical to scaling the AI factory.
So do your engineer talk to you, tell you they like the challenge, right?
Always, you know,
Okay.
they always love the challenge. Yeah.
So, well, Mike, you've been
Me
waiting.
too.
Fully.
Mike, you've been waiting patiently over there. Tell us about Quanta and QCT's approach to AI factories. I mean, it's amazing what you guys are doing. I remember thinking about you as ODM for PCs, and now you've evolved so much.
Yeah, I think AI factory is a very interesting topic. And I think from an ODM point of view, this is really something because of, what is AI factory? I've been, also trying my best, try to understand more about this from Jensen, and also how to, collaborate with my internal team, not only just the hardware, but also the software. Then I figured out that AI factory is a, especially QCT AI factory, it's designed to turn your vision into reality. And, we actually also transform your data, your token into a practical and AI-driven intelligence output. That is the token out. So, in short, AI factory, you can treat it as a token in, token out. But I think AI factory, the most important thing, the core thing is AI infrastructure. The infrastructure is including the server storage network, management tool, and even the facility. But not only just that, but also, we need to work with the open de facto kind of partnership, the ecosystem. So companies like, NVIDIA, ML Common, and also Hugging Face, and et cetera, to support enterprise with ML ops, DevOps, and also multi-modelings. And the AI factory is not only just these two, but the most important thing is from the business point of view, you need to fulfill customers' requirement. So from the vertical industry, how you fulfill their use cases with the AI embedded, that's another thing. So we try our best to integrate the whole thing and to speak the same language with our customers and to provide the best fit solution for them. So this is, I think, is what we are calling the AI factory. And from Quanta and QCT's point of view, we've been facing this into our server factory, our manufacturing. And we find out because of the Omniverse, because of the digital twins, it helps us improve the labor cost, cut down 50%, and in terms of productivity, increase 30%. And the most important thing is when we change the line, do the production planning, it also helps us to reduce the time, cut it in half. So I think basically this is the target that we're working on, and which is very much in line with Jensen's idea.
Yep, right. What I learned from NVIDIA is that the AI factory actually is token creations, token factories, right?
Yes.
And
Yeah.
take TSMC, for example, we always expect TSMC to increase the capacity, right?
Yeah.
So we expect the AI factory to create more token and to create more money.
Yes, that's how I said it. Business model.
Yes.
Yeah.
And so again, the question for Mike is that can you discuss how you work with NVIDIA partners to develop the advanced server platform? Right.
Okay, I think this is a wonderful journey. I think I still recall that at the beginning stage, we start, my engineering team started working with NVIDIA from the DGX-1. I think everybody knows that's the first GPU server for NVIDIA in 2014, 15. So it's been almost 10 years. And since then, up to 2021, we've been working with NVIDIA for generations of HGX server machine for QCT, OTS of the shelf product, and not only just that, but also tier 1 CSP customers' AI server.
Okay.
So with this, so we develop ourselves, become a good bridge between NVIDIA and the CSPs, NVIDIA and the enterprises. So this helps. So with these years, so we've been working with HGX. Let's talk a little bit about MGX. MGX is a very creative modular design architecture project, which allows all the customers can catch up, keep up with NVIDIA's product strategy 1 year reason. Because with this, so now you can see that NVIDIA expedite, pull in the schedule of their plan in rack level, scale up to GP200, NVL72. So with both parties' collaboration, and within this project, Quanta QCT, we also provide a lot of system design, system boards design, and also like a mechanical and also thermal design. So I think this is a wonderful contribution, and we love the journey with NVIDIA.
And challenging, right?
Yeah, well, don't even mention about
Yes,
that.
yes.
Always, challenges work with NVIDIA. Because Jensen, I think he's always very, outrageous.
Creative.
Yeah, creative. So always we need to keep up with, his thinking.
Yeah, additional question here. You mentioned the 1 year RIP, right?
Yep.
Yeah, the first time I heard that, I was very surprised because that's a very fast pace, right? So, yeah, so you and also maybe the TSMC and the other companies, vendors must also face the challenges.
Yeah.
Try to keep up with NVIDIA.
It's
right?
it's a big challenge for this industry because usually, for x86, this kind of product lined up usually takes a longer time, So
yeah, mature.
But comparing to speed of light,
Okay.
NVIDIA, this is different. So originally, when Jensen mentioned about 1 year reason, everybody, especially from my engineering team, just say,
Whoa.
"What? Are you sure you want to do this with all the new advanced technology?"
Yeah.
That is more important. It's not mature
Yes.
technology, but we take the challenges.
Yeah, but you did it. You did
Yeah,
that.
we did it. Yeah, but I
Talking
think we
about
did.
challenge,
Yeah.
just preparing this pre-game show thing, the change speed of NVIDIA's staff worker is amazing.
In the last
Every
5 minutes,
minute.
NVIDIA just launched a new chip.
Yeah.
Well, that's great. Hey, Jonney, let's turn to you. I remember listening to you 20 years ago as a player in PCs, but how did you evolve? How did you get ASUS to evolve to be an AI infrastructure company and now partner with NVIDIA for these next-gen systems?
Okay, our strategy is to go all in on AI. Okay? At ASUS, we have a comprehensive AI strategy called Ubiquitous AI, Incredible Possibilities, which aims to integrate artificial intelligence across all facets of business, from the cloud to the edge to PCs and end devices like phones and robots, making AI accessible to everyone, everywhere. We also invest heavily in software development, from the infrastructure layer to the system software platform layer, including our vital ASUS AFS, AI Foundry Service, ASUS AI Hub, AIDC, ASUS Infrastructure Deploy Center, and ACC, ASUS Control Center. And to the application layer, like smart medical, smart manufacturing, smart retail, and smart city, and so on, our goal is to provide an end-to-end AI factory service that includes design, manufacturing, and service. Yeah. Thanks to the national level Taiwan supercomputer project, which we took the major responsibility for, we have established a full spectrum of capabilities from hardware to software to support NVIDIA's magnificent AI factory vision. Beyond that, we've established global server manufacturing facilities at major global locations to further shorten the supply chain for our worldwide customers. One of our unique strengths is that we have over 2,200 locations globally to serve customers, including tailor-made SLA end-to-end solution services, and work closely with major vendors and partners worldwide. Our successful cases cover Taiwan, Japan, Korea, India, US, Europe, Middle East, and many countries in Southeast Asia.
Thanks, Jonney.
Thank you.
Yeah, again, a lot of insight here. Yeah.
Thank you.
And Eva, the next question is important. As we are now in GTC Taipei at
Yes.
COMPUTEX Taiwan, right? So I believe Chen Micro is a Taiwan-based company. And could you share us what's a unique advantage come from being a Taiwanese-based company?
Well, actually, Chen Micro is the only global software company that is originated from Asia.
Okay,
We are the
true.
largest one that is originated from Asia. And so software is the part that we are very unique. In Taiwan, we are so famous with all this hardware manufacturer, TSMC, and all these muscle guys. And but last year's GTC, actually last year's COMPUTEX, when Jensen shows the map of the supply chain and the little Taiwan in there, Chen Micro was the logo underneath there, and we were the only software company. When I saw the map, my tear almost come down. You know, it's so
I understand.
heart-beating. So I think this time the AI security, AI factory, is actually originated from the software factory. You know, last time Jensen was talking about this AI factory, and he said he called all the software engineers as the software factory worker. I was saying, oh, thank you very much for calling me. Like, I thought I'm the white collar worker. Now I'm the all-chew black hats, right? But that's, I think, is what AI factory means, right? If you transform from software factory to AI factory, this whole ecosystem is going to change. I believe Taiwan should play an even bigger role in the whole IT industry, not just the hardware computing power manufacturing, but the integration of software, hardware together to solve customers' AI question and problem infrastructure.
New factory concept.
Right, that's the new factory concept. Before, hardware company like ASUS, they pay software. They pay Microsoft a lot of money to bundle this operating system, right? The margin from, I've been joking, but truthfully, I think if Jensen can convince Trump that all the software worker is actually manufacturing worker, then Trump's dream of moving manufacturing back to US is already done, right? Software worker are factory manufacturing workers, right? So, so overall, I just want to say, I believe this AI factory concept will change the whole ecosystem of
exactly.
IT, and then working together with the computing power and the software application,
Yep.
then we can provide the best IT infrastructure, AI infrastructure for the whole world.
Hey, how are you?
Nice to see you.
Hey,
You guys look good on TV.
thank you.
You guys are you're like broadcasted to this giant movie theater. You guys are gigantic.
This is a very professional studio.
It is a
Right.
professional studio for professionals. Sit down,
We
sit
have
down.
partner here. You are going to sing solo in the show.
No, I was
Our
over there
honor
watching
to warm
you
up
guys.
for you.
No, so this is what happened last time. This is what happened last night. So it takes 2 hours, at least, maybe 3 hours to seat all the people.
Right.
Because they've been waiting in line for hours.
Yes.
And it takes a long time and so we came up with a good idea. Let's do a pregame show.
Yeah.
And a pregame show of industry experts, just like NFL football. They're all, you know,
Yeah.
they're all coaches and, right?
Thank you. Our honor.
Okay?
Our honor. Yeah.
And so it's a pregame show of experts. And this is what happened. So after GTC, they asked all the audience, they enjoyed the pregame show more than the keynote.
I don't know about that.
I think they enjoy your dentist delivery.
They want to know your insight. Yeah.
So anyhow,
This year.
anyhow, I'm so happy you guys are here to do this.
Thank
All right,
you.
all right, finish your job.
Thank you.
Thank you very much.
You do your
Thank you.
job.
All right.
I'll do my job.
See you in a bit. You got somewhere to go.
Yes.
Oh, what a big surprise.
Yeah. What a big surprise.
How
Right.
can he have so much time bumping here and there?
It's super. It's super.
What'd you think about that, Mike?
Oh, you know, Jensen is always a big surprise to us. Not only just from the technology, you know, product, but also the business model. As he just
Yeah.
mentioned about, you know, AI factory, you know, he turned the technology become kind of monetization. I think this is quite impressive. Yeah, always very creative, innovative. That's how I know him. Yeah.
A true leader in every way.
Yeah.
What are you looking forward to seeing today, Jonney, in
Oh.
summary?
Okay, I think one thing I would also like to take this opportunity to highlight is that recently people may have misinterpreted, you know, the impact of DeepSeek.
Yeah.
My belief is that, you know, it actually echoes Jensen's vision of AI factory.
Yeah.
It further popularizes intelligence manufacturing.
Yes.
I jokingly called it, you know, the poor man's Chinese Kung Fu. We have been watching them for more than 1 year since the publication of their first MAOA paper, which we were very impressed by. And then the following, you know, MOE, R1,
Yeah.
and distillation are all very impressive and solid, which also enables, you know, small models to blossom like wildflowers.
Yes.
Imagine one day the world will be full of AI brains.
Yes.
Yeah,
Yes.
that come in different forms and, you know, and sizes, including super, big, medium, small, and even tiny, from the cloud to the edge,
H. Yes.
to PCs and end devices
Yep.
like phones and robots.
Yeah. And
We are all very, very excited, you know. Super
Sure, Eva.
excited. Yeah.
What did Jensen inspire you in closing to say?
Well, I actually will say last time he talked a lot about sovereign AI. And when Trend Micro actually is very big in Europe and in AMEA, all the countries, the government sector. And that is the strong demand that I'm seeing, that sovereign AI. And just like
Sovereign.
Jonney say,
Yep.
every country will want their own brand, right? And then every enterprise will have their domain knowledge, their IP in their own brand. So 国有国法家有家规, right? That's what we usually say. So I think what Jensen inspiring me and a lot of the software people is thinking about all this AI is not just one big open AI, right? It's every enterprise, every country will have their own AI.
The new universe.
Yes.
Yeah.
Well, thanks so much. Thanks. A lot of great comments out of you all from the security side all the way to the AI factories, these great partners. Thanks a lot for joining us.
Thank you.
Thank you.
Thank
Excellent
you.
discussion.
Thank you.
Look forward to
Thank
talking
you.
a lot more in the future.
Thank you.
so much.
Thank you very much.
So as a reminder to our viewers, Jensen's keynote is coming up at the top of the hour. But before that, let's take a look at how Taiwanese companies and NVIDIA together are advancing physical AI to the next frontier. We're so excited to discuss the world of robotics with Scott Huang, COO of Techman Robot, a division of Quanta who helps companies develop robots. We also have Dr. Peter Peng, Director of Delta Electronics Robotics and Smart Manufacturing Divisions, and finally, Brand Cheng, Chairman and CEO of Foxconn Industrial Internet. Thanks, gentlemen.
Thank you. Good morning. Thank you. Good morning.
Hi, Scott. Welcome. Yeah. And I have a question. We know the robot in your Techman has a collaborative robot we call Cobot, right? So it's a vision-based robot, right? Could you help tell us about what role did you see the Techman playing in the next wave of intelligence manufacturing, especially in Taiwan? And any practical example, use case you can share with us?
Yes, and actually, we started cobot development around 13 years ago, and actually the cobot we have is vision embedded. So in the beginning, we think the vision capability is a must to have for the collaborative robot. So we not just provide the cobot, the motion only. So for example, the vision here, we build in, and it's native. So the capability for a robot is a must to have. So in that timing, we provide a smart robot, collaborative robot for our customer. The differentiation compared with industrial robot is a gap. So because traditional robot, what do they have? The sensing only the motor angle they have in traditional robot, because just they do some movement, one point to another point. So the computing power for the robot, right, industrial robot, is just motion. Only 6 of degree of freedom, so the computing is very easy. But once the intelligence comes, the vision is most important for the robot, like a human, right? We can understand the environment, we can reasoning, we can planning what we would like to do. That's why we have this capability. Most important is the vision. So 13 years ago, we think it's a must to have. If we compare the worldwide, I think we are very few company is, vision is built in our robot. So in that timing, so we, that's around few years, we cooperate with a Taiwan, manufacturer company.
Yep.
Yeah, for example, semiconductor, and electronics, even CNC machinery, those of the manufacturer. And what they need is an intelligent solution for them. Why they needed intelligent? Because if you just take one object from one point to another point, like the brain work to do these things. But we have the vision. So in their, for example, for CNC, in their production, their object come, the object don't need to fix in one precise position, because our vision, we can do positioning, compensate the variation and the pick, and after, process. And we also can check the quality, maybe some scratch and the AI function we are run. For sure, we also few, correct robot or industrial robot, the control bus, we embedded NVIDIA GPU inside. So we can do AI inference in our control bus. So like edge computing.
I see. So that means the robot can do the calibration by itself, and also can recognize the image, and also can make some intelligence movement by itself, right?
Yes.
And with the box below, embedded with NVIDIA GPU, it can do some high-level language model or something, right?
Yes.
Yeah. So today you bring the robot. Is that the real robot or just the mini one?
Sure, it's a toy, but
okay.
Our the terminal robot is I think it's easy for.
I understand.
You understand what the difference, because you can see there's the vision here. Yeah.
Well, thanks. Hey, Peter, can you talk about your collaboration between Delta and NVIDIA? Maybe focus on the integration of your D-Bot series of robots with NVIDIA's Omniverse?
Sure, of course. Actually, we are producing a lot of different kind of products for data center related, of course, included NVIDIA. And we are building the power modules for the data centers related. But our production line didn't really can be optimized or remote control the quality so easily. Yet, we have the chance to cooperate with NVIDIA, and based on the Omniverse, and combine with our, we call machine and robot twin, that can, based on our edge computing, connecting our machine and robot immediately, real-timely, return the necessary critical parameters and back to remote. For example, our production line in Thailand, in somewhere else in the world, but we can remote monitoring, measuring, and even calibrate, like Scott just mentioned, the robotics. While the machine have some strange things happened, we can remote calibrate based on the Omniverse, thanks to the Omniverse. And we have the beginning from the real to sim. We have the real production line, but together with Omniverse, it becomes better. And that is not enough. People need, we need to have much more productivity. Like Jensen just shared with us the day before, yesterday, mentioned about people used to consider cost down. But now, more and more productivities. But from our side, we need to be balanced. So for the new production line, can we do from sim to real or not? Can we minimize the unnecessary waste as much as possible? So we also cooperate to based on the Omniverse to do the virtual design, even from the very beginning of the product design. And then later on for the related machine, robotics, together with the necessary process technology to make the products correct and make the customer satisfied. So based on Omniverse, again, we do from sim to real. That means we don't need to really build the production line so soon, but we can make sure everything that almost like the reality and minimize the try and error after. So we cooperate with NVIDIA so closely from real to sim and sim to real. Okay. So this is what we have done, and we will continuously do not only for the robots, but machine, process, the whole production line. And actually this afternoon we will show the whole factory's simulation as well.
Mm-hmm. Thanks. Well, hey, Brand, great to see you. I mean, you're a company that we look at in our work very closely from your work with iPhones to smartphones to everything. But this robotics initiative is really amazing, and I think it needs more coverage. I was wondering, how did FII and NVIDIA first start working together and collaborating?
Okay, so probably people know we are running lots of manufacturing for the electronics. So we have the entire Foxconn group have more than 200 campuses over the world. So just like what Jensen mentioned, the evolution trend of AI, from perceived AI to generative AI to agentic AI, even up to physical AI, we gradually follow on this. So back to 2016, we built the HPC with NVIDIA solution for medical research. We do not only make the smart manufacturing, but also like medical research to help something like a medical simulation, like 3D rendering in terms of tumor research. The first two, we engage with NVIDIA to build a cluster of a V100 in Wisconsin. Probably some of people know that we have a very big campus in Wisconsin to produce the electronics product over there, which we leverage the machine learning and start to use a lot of tools. But back to 2023, when Gen AI was booming. So we start to look at that, how to leverage the rapids under the ISAC. So the complexity of material moving on the workshop is very complicated. So how are you going to use AI? So we do train the AI model to move the material and send a signal to the material tower, also correlated to the AGV, to the AMR, to the robotics. So actually, we make an ecosystem about this, to drive the material handling. And at the end, the impact is like we improve the unit per hour per person about 73%. With these AI models, with AGV, AMR together, we reduce the delivery cycle time about 25%.
Whoa.
Yeah. And more than that, at the worst, we are thinking how to raise up the automation level, because in a lot of manufacturing process, if you look at that, some things you really can do the automation and put robotics inside, but for some material, maybe very soft, very flexible, then you need more, something more beyond than robot arm or AMR or AGV, which maybe you need humanoid robots. So we are studying on this, to put into the production line, into simulated process, and toward implement like a physical AI eventually. So we can resolve all these issues and really make entire production line fully automated. So with this, as an example, I believe a lot of companies, especially Taiwanese, Asian company, like to invest in Vietnam in this era, right, in this decade. A lot of people think about that. In Vietnam, maybe the labor costs are cheaper, they have many people. Actually, this is wrong. Vietnam, probably their population less than 100 million. Compared to China, it's about nothing. So actually, the automation level we have in Vietnam is very high. You know why? Because they don't have so many technicians which can repair the machine, can optimize the parameters, right? Can coordinate the layout and so on. So we implement AI model. We implement AI technologies to make it easier. Then how are you going to enlarge this? So we use Omniverse. So back to Vietnam and the factory we have in Taiwan, you can see that in 2024, both our factory in Taiwan and in Vietnam got certified by World Economic Forum as a lighthouse factory. So the lighthouse factory is not just automation, but also come with a lot of agentic AI application already. And the server factory we have in Taiwan is the first one in the world for the server, as a lighthouse factory. So going forward, just like Dr. Peng said that, we leverage NVIDIA, work very closely on Omniverse. How you're going to reduce your cycle time, how you're going to drive high accuracy, high efficiency, high consistency for your operation when we have more than 200 campuses for the same product, Omniverse. With Omniverse, with the Isaac platform NVIDIA have, we work on robotics, then also lots of LLM training. Then we can keep moving forward to duplicate. Then we can do simulation, we can do validation, we can do decision making. At the end, we measure everything before we deployment.
You're a pretty good Omniverse salesman, by the way.
Oh, really? Because I'm doing that. I have a whole bunch of team doing this because
got it.
The thing is, we faced challenge before. Now we see the solution. So we need to adopt invented solution to resolve all issue we have, right? So we can overcome. Yeah, so we can overcome the challenges coming along the way.
Yeah. Thanks. A lot of good insight, and I always like to hear about the use cases, and you to bring a lot of use cases. Yeah. And next question is to Peter. I think we have some discussion yesterday or a few days ago, right?
Yes.
So could you tell us how is the partnership with the NVIDIA simulation accuracy and also help to accelerate the development of robot solutions?
Of course, sure. Just right after Brent just mentioned, we are so pleased and thanks to the NVIDIA related USD and that so wonderful universal scenery descriptor that connect all different kind of tools that we are using for the old times, but nowadays all connect together. And just like we just discussed, how Isaac Sim can help us. How Isaac Sim can help us. For example, we do the kinematics of the robots for long times, but that is not enough. It must integrate with the necessary critical process who really makes the product come true together. And again, together with Omniverse, not only Isaac Sim, but also Isaac Gym, that we can pair processing much speeder because pair processing and the speed can be double and double. And also, one very critical, important secret is, can we do the machine for producing the product at the beginning? Not wait until the prototype almost complete. That could be too late already. Okay. So we are appreciating the Omniverse supplied a world foundation model and that the Q-Curious can support multi-user at the same time in the same space.
And can duplicate to the other.
For example, when you are design product, maybe you are too busy, no time, but we can see what you are doing and then we can consider, okay, we know what Brady is thinking right now, so we have to match, synchronized, cooperate, concurrent engineering at the same time. So, mention about again what Jensen just mentioned, the cost is very important, the productivity is important, and also the cycle time is very important. And we are wondering if we can secure the quality. That means what? Do the right thing right at the first time. So if we can do the job well at the beginning, together, synchronized. It's an idea before, but nowadays, thanks to Omniverse, we have the chance to do it together at the beginning. Then we can synchronize from time to time to make the unnecessary waste down to the minimum. So how about the speed? Must be very fast, right?
Yeah.
The world is changing.
And efficiency.
Accelerations, so we need to be flexible and quick. So about, for example, our company's robot. I start my first job 40 years ago for robots, very, very old time. And I start from industrial robot, collaborative robot. Our depot collaborative robot is not only a robot, but much more important, it's a solutions that can really solve the end customer's problem, not only motions, but process. And thanks again to Omniverse, the simulations becomes much more real. You mentioned the accuracy. How can we do it? Not only kinematics, but the dynamics. How about you thinking the skin the material, the all kinds of physical that we cannot identify so clear before. And also at the same time, we used to do a lot of process simulation, for example, by using ANSYS. Nowadays, that all can be connected with Omniverse, or even just do it in Omniverse. So a lot of challenge coming, but still I believe together with Omniverse, we can conquer so many things. Not only the machine, not only the production line, but the whole factory.
Just quickly, Scott, wanted to ask you one more question.
Okay.
You know, robots used to follow scripts.
Yes.
Now they adapt and learn in the field, go around and learn. How did you deal with that in work in industrial robots? How did your team adapt and work with that in the industrial setting?
Yes. I think that for the robot, right, actually is some challenge we need to solve. And for example, for sure, the smart robot is needed for the end customer, but how easy for the engineer, they can, implement the solution in their production line. Currently, in automation industry, actually is still a gap. So we try to provide a very easy to use solution for our customer and our partners. So for example, in the tradition, right, just mentioned is only the angle of the motor we have, they have, but now the vision images come and the force sense feedback it also have, and also AI power is come, and the next step is so the very powerful function, how engineer can what they can do, writing the code. I think is another good thing for them. So it takes a lot of time. So what we are doing is the first thing is hardware portion. Hardware is easy, ready to go. What I mean ready to go. So it means once the robot, right, they have the robot, and we also provide the autofocus camera in our system, so they can for position, and one is a sensor inside, force sensor inside. So then what they have is for hardware already one platform, and the second thing is the software.
Yeah. Well, we're almost out of time, but Brand, let's start with you. Wanted to see what you're excited that maybe Jensen could say today. What are you excited about? We'll go down the line. We really appreciate you being here.
Yeah, I think this is the AI era, very important. So back to us. When we are running such scale of global operation, we do need to leverage the new technology. Peter mentioned Omniverse, Scott mentioned about robots. So you look at that, the Gen AI essentially require data, require computing power, require algorithm or AI model. So as the leading company for smart manufacturing in the world, I think Foxconn Group is driving. We collect all kind of manufacturing data. You know that, right? So second thing is we built gradually a lot of computing power from Kaohsiung. Now we have H100, H200 all implement there. Then move to Wisconsin, we have a V100, which was built in 2020. And also we have the computing power in China with H20. Then we are going to build, we already built the GB200, 4 racks in Kaohsiung for the R&D purpose. So going forward, we got to even build more. Like, I think the Chairman Yang Liu, Foxconn Group, mentioned that we're going to build 64 racks in Kaohsiung as the initial one. And moving forward, probably you heard about that. Foxconn Group invests a lot in Houston. We're going to build more the computing power with GB200 or 300 in Houston to help us out. So with this, then we start to run the AI model algorithm. How are we going to make it? Again, Omniverse.
Got it.
Omniverse.
Yeah.
And any quick words, Peter?
Oh yes, I really want to share with everybody. Omniverse perception sensing capability really makes Omniverse not just people thinking virtual side, but connect to the real side very closely. And from the what we try to challenge, overcome, for example, the computation powers that we require from the traditional robot to cooperative robot, cognitive robot with sensing, like Scott mentioned, and also humanoid robot like. Why? Because the automation last mile still using a lot of human operations with high skill. That still needs a lot of help. But thanks to Omniverse, again, there is a very high degree of freedom, human models that can really helpful for this. So again, thanks to NVIDIA's computation powers, we can do not only the cloud, but also the edge, but also embodied that not only agentic, but also physical AI. And thanks to everybody again, hope we can fight for a better future. Thank you.
Great. Thanks a lot. Yeah, go ahead.
So actually, you know, the next generation in the future for the COBA, right? How say reasoning and planning is very important. Now it's the how say, so currently we use the Omniverse, the Cosmos.
Yep.
But as I said, so the foundation model, like the cool motion, like that's a foundation model, and we are use, and we also generate the synthetic data, SMG. Now we are trying, and we are modify the AI model currently. So we hope in near future we will have more capability for example, reasoning and planning for the COBOL.
I think you will. I think you will. Thanks a lot. Thanks to all of you for joining us. That was great. Well, what a great session. So Brady, you know, you're a local AI expert and Foundry. What did you think about what was going on, what you heard today?
Yeah, I think it's a critical point, especially in Taiwan, because we are the center of the chip productions and also system productions, and we a lot of robot vendors are working with NVIDIA. So I think it's a good opportunity for Taiwanese companies to start in the robotics industry. Yeah. And Ben, how about you? Being a respected AI research analyst in the world of finance, what stood out to you?
I think, you know, Brady, I'm really impressed by how fast people are moving in Taiwan, all these partners, and what it takes from NVIDIA's side to integrate all these partners, manage all these relationships, and move at this speed, and then bring along all these partners who are moving really fast as well. You can see it with Dell and Asus and Quanta and all the folks we spoke to are moving so fast. I've never seen it like this in order to keep up with Jensen's speed of light. And it's amazing. And I'm really looking forward to what he says today. And I think this community here in Taiwan is, I can feel it after being here a few days. It's so strong in terms of, you know, the pride in what NVIDIA is doing and the desire to work with this company. It's very impressive. And I think that, you know, today, what is really clear is that he's a very strong ecosystem here in Taiwan and both globally, and everybody's looking forward to what he has to say to drive the industry forward. We were lucky enough to hear a lot about robotics today, which is one of the next frontiers, but there's a lot of other things I think he's going to say, and it's going to pull this whole island forward, and it's really exciting to see.
Yes.
So I wanted to also just say thank you all for joining us here at NVIDIA GTC Live at COMPUTEX. The countdown is on to Jensen's keynote. It's coming up really soon. And as you see, people are still filing in. So we got to get to our seats, and Brady and I got to get moving.
Thanks for watching. I can't wait to see the keynote from Jensen.